Hello, and welcome to today's lesson. We're looking at Area Volume Unit 3, Lesson 5. We are going to find the area of an annulus. Okay, so an annulus is the region between two concentric circles. Okay, we looked at concentric circles in an earlier unit. Remember, concentric circles are circles that share the same center and then have different radii. So what you want to think about, and this goes right into our last lesson that we had about circle segments. How can we find the shaded region of this circle? So when we're looking at finding the area of an annulus, once again, think about the picture. How do I get this shaded region? I have the area of my large circle, and then what I have to do is I have to take away, and we can use Homer, donuts, to help us out. We need to take away the center of that donut. So mathematically, how do we take things away? We just subtract. So we need the area of the big circle minus the area of the small circle. So our area is going to be 9 squared pi minus 3 squared pi. And then all we do is just work through to simplify as much as possible. 9 squared is 81, so we have 81 pi minus 9 pi. Okay, combine those two terms and we get a 72 pi. And that is our answer for the area of the annulus. But remember, start with the picture. Whenever you're not dealing with a basic shape, draw the image. What are you putting together? What are you taking apart to try to get that answer? Okay, now, a couple extra types of problems that we're going to have. We're going to combine some pieces here. Notice that we don't have a full annulus. We have a sector of an annulus. So once again, we got to start with what we know. We've got area of big circle minus area of little circle. And then once we find that answer, we don't want the whole answer. We want the shaded part, which is the out of 360 ratio that we can work with. But first, let's find what we're looking for here. Okay, area of big circle, radius 6. So we've got 6 squared pi minus the area of the small circle, radius 4 squared pi. We have 36 pi minus 16 pi. So the area, if this was a complete annulus, would be 20 pi. But now, this isn't a full annulus piece. What we have in this situation is a part of it. Now, we have to be careful. It's not 30 over 360. The 30 is what we don't want, so we're taking that away. So what we need for our area is we need the proportion 330 over 360 times 20, and let's just put that pi on the outside. Remember, leaving our values exact as long as possible. And in this case, we're always just trying to go to the calculator, help us out. So we have 330 times 20, okay, divided by 360. Okay, now, once again, in this situation, we don't have an exact value again. Okay, and that causes problems. And what we're looking for is we're looking for the simplification as much as possible. So we have 18 1/3. Now, if I had my TI calculator working here, what you can do is you can do the fraction conversion, and you can convert this decimal into the fraction, which is always a helpful tool overall, because if this was an exact decimal point, we could go with it. But since it's not an exact decimal point, what we need to do is we just need to start working on some simplification. So we've got 2, we've got 18. Now we can take a 6 out of both of these, it looks like. So let's see what 330 divided by 6 is. 55. So this simplifies down in its simplest terms to 55 thirds pi. And remember, we're always trying to get it as exact as possible. All right, last problem that we're going to look at here for today. Now we need to find the radius. Okay, once again, everything follows from our basic formula. Area of big circle minus area of little circle. And in this case, we know that this region is 11 pi. So we know what the answer is, 11 pi. We know that the outer circle is a 6 radius. So we have 6 squared pi. We know our inner circle is r squared pi. Once again, notice a pi in every value. Okay, that's our best case scenario, because if there's a pi in every value in the equation, we can divide it out and make our work a little easier. So 11 equals 36 minus r squared. And now we can go through and solve from there. Subtract 36 from both sides. We get minus 25 equals minus r squared. Divide out the negative 1 to make them both positive, and then we will square root both sides. Okay, when we square root, we get r equals 5. Okay, now, makes sense. Always check your answer. Is 5 less than 6? Yes, so that makes sense. It looks like a good value, and here we're dealing with centimeters. Okay, so I was not completely truthful. One more problem. Okay, so now we're working with the sector. Okay, what we're trying to do, we have the shaded region area again, 20 pi. What we need to know is x. So we've got an x out of 360. That's the proportion of the sector that we're looking for. And remember, big circle minus little circle. 20 squared pi minus 16 squared pi, and we're just wanting to work our way through doing the solving. Once again, identify whenever possible to get rid of the pi value if you can. If there is a pi in every term, and if I distributed here, there would be a pi in all 3 terms, we can get rid of that pi to make our work a little bit easier. 20 equals x over 360. And then we just need to do 20 squared minus 16 squared. Okay, so 20 squared is, 20 times 20, there we go. Is 400. 16 times 16, I don't know why I was having a hard time with 20 squared just being 400. I wanted more zeros there. That's what was going through my head. So we have 400 minus 256. We get 144. Okay, so the 144 can go up with the x, and this is once again where we get to our ratio situation to help us solve. So we have 20 over 1 equals 144x over 360. And then we can cross multiply to get a single line equation. 144x equals 7,200. And then we divide both sides by 144 to find that degree measure. Okay, so we had 360 times 20. Okay, that's how we finish that piece out, divided by our 144. Okay, and that gives us 50 for x. So x equals 50 degrees. Now that concludes our lesson for today. Thank you, and good luck on the homework.